Okay, so we're going to talk about geological processes here. And so many of the non-renewable natural resources that we use were formed millions of years ago, and due to geological processes or changes to the material that make up Earth. So that's what geological processes is. It is changes to the materials that make up Earth, okay? Okay, so it took millions of years for the iron deposit to form. This is an iron, they're hauling out iron here. This is an iron pit. If we extract it faster than it can be replaced, there will be no more iron here, right? So then what are they going to do with this hole here? Just going to be there, right? Okay. So let's look right here. Geological processes. So geological processes that affect natural resource formation includes igneous processes, and that involves lava or magma. You know, like igneous rocks. Actually, I think Bob here, you know, my pet rock, Bob is igneous. So, and how do I know? Because it's smooth. It's smooth, and you can see different colors of stuff in there. It's been hot. It's melted. It's been hot. It melted. You can see different little stripes, different colors of stuff. So this is an igneous rock. It's been through the igneous process. So that involves lava or magma. And then you have the metamorphic processes, and that involves heat or pressure, right? This is inside the earth. And then you have surface processes, that's outside the earth. And then you have sedimentary process, and that involves sediment. And where you get sediment at is if you got like a big ocean somewhere and things die, and what do they do when they die? Fall to the bottom, right? And it just builds up over time. And you can kind of see a little bit of that here, some sediment along those cliffs there. Okay, and this is granite. We have granite in the Wichita Mountains. There's some granite out there. This granite formed when magma cooled slowly underground, which is an igneous process, right? Okay. Okay, so let's look at some igneous processes, and you can see here. That igneous processes involve the cooling and solidification. That means liquid becomes a solid. Michael, can you close that door for me, please? Lock it. So igneous processes involve the cooling and solidification of magma or lava. In other words, lava and magma, that's really hot liquid rock, and then it cools, right? And so that's what they call solidification. Okay, so look right here. Here's a diamond crystal, and these form at about 200 kilometers, which would be about 120 miles down. That's where they form. Diamonds form at depths of 200 kilometers as a result of intense pressure. Magma then carries the crystals to the surface of the earth. So here's some diamonds down in here, and then so they get carried up to the surface there. Boom, and just blown out of a volcano, right? Okay. And then you have something called hydrothermal activities. What's hydro mean? Water, good. And thermal is what? Means what? Heat, right? So hot water. So hydrothermal activities. So as some magma cools and crystallizes, hot water solutions rich with mineral are released. And these hydrothermal fluids may seep through cracks in the earth and produce deposits of important minerals. Okay. You can see here, these are gold, silver, copper, and so on. Here's the magma here. Here's the hydrothermal fluid. There's water that's comes from precipitation, like runoff, or the water has soaked through the ground and found its way down here. Okay. Okay. So large deposits of gold, lead, zinc, and silver in the United States are due to hydrothermal activities. Okay. Okay. Any questions about that one? Hydro and thermal, right? Hydro is water, thermal is heat, so hot water. So let's look, here's some more hydrothermal activity. Hydrothermal fluids are found in the deep ocean as well as on Earth's surface in hot springs. Now these right here, look at these right here. This is boiling hot, mineral rich fluids that come out, coming through vents. So they're coming up from the earth, inside the earth. And these hydrothermal areas can be rich in sulfide deposits. So if you're anywhere near there, guess what? It's gonna smell like rotten eggs, because that's what sulfur smells like. Okay. Okay. So here's our first question here. Let's look right here. Igneous processes that form natural resources may involve what? Look here. Let's look and see. There's three of these are three that it involves. Are you looking here? There's three things that involves igneous processes that form natural resources may involve what? Magma, ammonia, hydrothermal fluids, or cooling and solidification of lava. We talked about three of those. One of those things we didn't even mention. So the three that we talked about, those are the three you're gonna mark. Got an answer for me there? Three of those things we talked about. One of those things we didn't. You're gonna mark the three that we talked about. Okay, everybody got an answer? Okay. Let's move on here. We'll grade those here shortly. Okay, let's look right here. Hydrothermal activity in deep ocean and in the hot springs is a source of what? Diamonds or sulfide? Hydrothermal activity is a source of what? Diamonds or sulfide? Mark your answer. Diamonds or sulfide? We just talked about that right here. Okay. Diamonds or sulfide, these hydrothermal activities in the ocean and in the hot springs. What do we get from those? It's a source of something. Diamonds or sulfides? Mark your answer. Okay. Diamonds are formed at great depths, at least 200 kilometers or about. And the crystals are carried to the surface by magma. Is that a true statement or a false statement? They're formed about 200 kilometers. That's about 120 miles or so. True or false? Mark your answer. I'm moving on here. Okay. Okay, so let's look at, so that was the igneous processes, right? Let's look at some metamorphic processes. Okay, so let's look right here. Contact metamorphism occurs when hot magma seeps into surrounding cooler rock, and this causes the surrounding rock to change its form and composition, which is what metamorphic means, right? Change. Okay, so some metallic minerals associated with contact metamorphism are zinc, lead, copper, and iron. Okay, so if you get any of these, they were involved with, these are the geological processes that they were involved in. They were involved with hot magma seeping through surrounding cooler rock, and it causes that rock to change its form and composition. And you get things like zinc, lead, copper, and iron out of the deal. Okay, now let's see what happens after that. So let's look at surface processes. So weathering is a surface process that is eventually responsible for the creation of soil. The materials left over after the rock breaks down are eventually combined with organic material, creating soil. Okay, you know what soil is, right? It's basically wore down rocks because of because of weathering. And then that's mixed with organic material. That means dead plants or dead animals, and that's soil. Okay, organic matter and bits of rock. That's what soil is. okay? So weathering occurs without the rocks moving, okay? The rocks don't move, okay? Weathering occurs without the rocks moving, so it should not be confused with erosion. So those rocks don't go anywhere, they stay right there, and they break down over millions of years, and then dead things find their way to it, mix in with those rocks, and it becomes soil. Okay, that's how we get soil. You go outside here and dig into the ground, and it's gonna be a combination of rocks, broke down, weathered rocks, and organic material. Organic material means things that were once living. Could be plants, could be animals, right? Okay. Let's look at more surface processes. Look here, this rock has been here probably at least 1 million years, possibly. Look here, could be here longer than 1 million years. Look at how that rock is broken up. You can tell it hadn't been moved just by the shape of it, right? Hadn't been moved. It's been there for millions of years probably. So physical weathering breaks rocks into smaller fragments with the same chemical makeup as the parent rock. So how did this happen here? So when water freezes in rock cracks, it expands and breaks a rock into pieces. That's probably what happened here. And you can see that over a 1 million year period. That'd be just so cool to walk up to a piece of rock like that, because you know it's been laying there for millions of years, and it hasn't gone anywhere, but it's had water inside the cracks there. Water freezes and expands, and it's moving them apart, right? Is that cool or what? Okay. So physical weathering breaks rock into smaller fragments with the same chemical makeup. In other words, it's still the same rock, it's just been weathered over the years. Constant freezing, expand, and so on, physical weathering. And then you have chemical weathering results in the production of new minerals with a different chemical composition. For example, acid rain reacts with rock, causing a chemical change to occur. So here's some here that were chemically changed through acid rain. And acid rain is all the junk that we throw up into the air, and then when it rains, it comes down into that, lands on these rocks, and changes their composition. Okay, that's chemical weathering. Okay. Let's look at some surface processes right here. Fresh water used for human and animal consumption is also affected by surface processes. Okay, you listening? This water can be found in lakes, rivers, streams, and wetlands. Okay. Oh, let's answer this question right here. Can you think of a process that would change the quality of fresh water available for human consumption? Anybody? How about acid rain? Would you want acid rain would you want that acid rain to be falling into the lake that you get your water out of? No. Okay. Okay, so let's look at the surface processes. So when it rains, water also seeps into the soil and down into the rocks beneath. See, there's rocks underneath the earth, right? That's what the earth is made of. So this water becomes stored beneath the earth's surfaces. Okay, here we go. Let's look right here. So here's a graph. These are transpiration by vegetation. You remember we talked about did we talk about transpiration in here, or was that another class? Transpiration is you got the leaves are wet. The leaves get wet from either like morning dew or whatever, or rain, and then that little bit of moisture on those leaves and on the limbs and so on evaporates into the sky. That's transpiration. And then you have look here, here's the ground, here's a stream, and look right here, here's aquifers, unconfined aquifer and a confined aquifer, and we'll talk a little bit about those. So rocks that are more porous, like a sponge, that's what porous means, kind of like a sponge, hold more water, right? This underground layer of water bearing rock is called an aquifer, okay? Aquifer. And you have two different kinds. You have unconfined aquifers, and then you have confined aquifers. The confined aquifers are, they've got rock in between there, okay? So let's look at this sedimentary process here. Here is a picture of, this is fossil fuels, such as coal, oil, and natural gas, or a natural energy resource that contains solar energy preserved from millions of years ago. Are you listening? Okay, when prehistoric animals and plants died, their remains were trapped in sedimentary layers of rock that accumulated with time over millions and millions of years, and maybe even a billion years. Okay, the layers at the bottom were changed by intense heat and pressure and became fossil fuel deposits, and this can be extracted today by drilling deep into the land and ocean floor. Now look right here. So here we are, here's a stream, here's a mountain, looks like a mountain area. Here's the grass and trees and plants and so on. And then you got the lithosphere, and then down here you got heat and pressure, that's the magma. And then you got sediments down here, carbon from dead plants, sea animals and plants. You get oil and gas out of the deal, okay, natural gas, okay. And you got a question about this? So these layers at the bottom here were changed by intense heat and pressure and became fossil fuel deposits. Okay, so here's our question here. Contact metamorphism occurs when cool rocks surround hot what? Contact metamorphism is that cool rock surrounds hot rock or hot air. Let's look at contact metamorphism again. We've slept a lot since. Let's look at contact metamorphism. Okay, so hot magma seeps into cooler rock. So let's look right here. Let's answer the question based on what we know now. Okay, so contact metamorphism occurs when cool rock surrounds what? Hot rock or hot air? Mark your answer. A or B. Everybody got an answer? I'm moving on here. Okay, physical and chemical weathering produce soil. Is that a true statement or a false statement? Be careful about that one. Is it physical and chemical weathering that produce soil? Mark your answer. Okay, a mineral that undergoes chemical weathering will produce smaller identical minerals. Oh, be careful with that one. Is that a true statement or a false statement? A mineral that undergoes chemical weathering will produce smaller identical minerals. Be careful. True or false? Mark your answer. Okay, to extract oil, one only needs to drill into Earth's surface until a sedimentary layer that's about 20 years old is reached. Oh my, are we going to find oil in 20-year-old sedimentary stuff? Oh, I don't know. Mark your answer. True or false? Okay, look right here, 24. The amount of water stored underground depends on which of the following. Is it how porous the rock is, the surface processes, rainwater, or the water cycle? I would say you could mark a bunch of those. Oh, yes, sirree, buddy. I'd mark a bunch of those if I were you. You can go back and look. The amount of water stored underground. You can go back and look at that slide. Okay. I'll tell you this, it's more than two. Probably more than three. Mark your answer. I'm moving on here. Okay, so we're going to stop right there. We're going to stop right there for the day. We're going to go back and, for you at home, you're going to view this video, you're viewing this video today, you view another video tomorrow, and then we're gonna have more questions. Don't submit those questions yet, just hold on to those, okay?